Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, today we're going to continue our lesson with chapter 3, sequences and series, lecture 2 of 2, 3.2, binomial expansion. And I do hope that all of you are ready with your lecture notes in your hand right now. Without wasting so much time, let's continue. Okay, before that, let me change the ink color of the pen here now. Okay. So at the end of this, objective of this topic students should be able to expand a plus b in bracket to the power of n, where n is a positive integer, write n notation, and we call factorial. This we call a factorial notation as here as a binomial coefficient. Determine the general term in binomial expansion of a plus b to the power of n, where n is a positive integer, and determine the expansion of 1 plus x to the power of n for x we call absolute modulus of x in less than 1, where n is a rational number. Okay, n is a rational number then. Okay, so class, for a plus 1, which I think that is easy for us, it's gonna be a plus b. Okay, for a plus b to the power of square, power of 2. Okay, class, before that, let me explain something here. Sometimes the student make a simple careless mistake here. Let's say a to the power of b, a plus b to the power of n. They simply, multiply with something like this here, a to the power of n plus b to the power of n, where this is incorrect. Okay, so please remember this. So when it comes to a plus b to the power of n, meaning it's gonna be a plus b multiplied with a plus b multiplied with until a plus b to the power of n. Okay, this one a plus b multiplied with a plus b n times. Okay. So look at this one here now, a plus b squared, meaning that is going to be a plus b multiplied with a plus b. Okay, it appears twice, 2 times. So they're going to come out with a times a squared. A times a squared. A times b, a b. B multiplied with a, another of a b. And b multiplied with b, b squared. Okay, so then simplify this as an a squared plus 2 times here, 2ab plus b squared. Okay, what about this one here now? A plus b multiplied with a plus b multiplied with a plus b. Okay, this appears 3 times or thrice here, 1, 2, 3. So look at this one here now. Okay, for this, we can refer to this one here now. A squared plus 2ab plus b squared multiplied with another of a plus b. So then look at this one here now. A squared multiplied with a cubed. A squared times b, then a squared b. Then it's turn for 2ab multiplied with a to a squared b, and then 2ab multiplied with b to a b squared. Plus with now is turn for b squared multiplied with a b squared, and then b squared with b cubed. So now let's simplify this. Okay, a cubed and b cubed, a to the power of 3. Then what I was having here now? A squared b to a squared b. So look at between this and this. A squared b, a squared b. So 1 plus 2 equal to 3a squared b. Then ab squared, ab squared. We got coefficient of 2 and 1 here. So it is 3ab squared then plus with the last one here, which is b cubed. Okay. So what about this one here now? Okay, so just imagine that we have a plus b multiplied with a plus b multiplied with another of a plus b and another of a plus b. You're going to expand. Okay, it's very long here. Simplify until you get, okay, you can just try yourself. Okay, test yourself what you will get then at the end of this one here. Okay, you try to expand and simplify. So I just give you the final answer. You try in the middle here. So it's gonna be a power of 4 plus 4a cubed b plus 6a square b square plus 4ab cubed plus b to the power of 4. Okay. So now let's look at this one here. This is kind of what we call the pattern of the coefficient of x, the coefficient of a and b. Okay. The coefficient of each of term in binomial expansion form an array which is known as Pascal triangle. It will give you such a beautiful pattern of numbers as a coefficient. Okay, the coefficient of the binomial expansion of this. So the first, okay, when n equal to 0, n equal to 1, 2, 3, okay, 4, and each number in Pascal triangle is sum of two adjacent in equal to in the previous row. So what is the meaning of this? Each number in the Pascal triangle is the sum of two numbers adjacent to it in the previous row. Can you tell me what is the meaning of all this? Look at this one, the first one here. 1 plus 1 equal to 2. 1 plus 2 equal to 3. 2 plus 1 equal to 3. 1 plus 3 equal to 4. 3 plus 3 equal to 6. 3 plus 1 equal to 4. Let's continue if we have n equal to 5. Let's see. If we call, it should be begin with 1 and end up with 1 here. Okay. So 1 plus 4 equal to 5. 4 plus 6 equal to, yes, good, it is 10. 6 plus 4 equal to, yes, another 10. 4 plus 1 equal to 5. And you may continue when n equal to 6, 7, 8, 9, 10. But mostly we're going to ask you until n 4 or 5. Okay, because it's long enough that. So expansion of a plus b to the power of n. So we got a, b to the power a plus b to the power of 3. So we get 1, 3. Okay, 1, 3, 3, 1. Just like this. 1, 3, 3, 1. Okay, so a plus b to the power of 4, we got 4. Okay, 1, 4, 6, 4, 1. The power of a decrease, the powers of a decrease by 1 and the power of b increase by 1. What's the meaning of this? Okay, look at this one here. Look at this. Okay, this is what we call coefficient. Bahasa Melayu, perkali. Okay, and then look at that a and b. A, B, A, B, and B here. So guys, girls, in this case, A, actually that there's a B here. A power of 4, B to the power of 0. 4, A cubed, B to the power of 1. 6, A square, B square. 4, A power of 1, b cubed. And here, actually, there is a to the power of 0, b to the power of 4. So look at this one here. The definition of this, the power of a decreased by 1. Decrease means berkurangan. The power of a from one term to another term, another term here. Look at the, we call the power of a. It begins with 4 because the n is 4 here. Begin with 4, 3, 2, 1, 0. And the power of b increased by 1. Now, look at this one here, b power of 0. Then b power of 1, b power of 2, power of 3, and the n here, b to the power of 4, because the n here is 4. Okay? The degree of each term is n. Look at this one here now. 4 plus 0 equal to 4. 3 plus 1 equal to 4. 2 plus 2 equal to 4. 1 plus 3 equal to 4. And 0 plus 4 equal to 4. The number of terms is plus n plus 1. Okay, when we have when the n is 4, how many terms do we have? The first term, second term, third term, fourth term, and fifth term. T1, T2, T3, T4, T5. Okay. And then the first term is a to the power of n, and the last term is b to the power of n. So when n equal to 4, the first term here, a to the power of 4, and the last term here is b to the power of 4. Meaning, if a to the power of 4 here, then b power of 0, and when b to the power of 4, a to the power of 0. Okay, so I explain one by one the definition of this by giving an example of a plus b in bracket to the power of 4. Okay, if you not understood, please rewind and listen and record my explanation again and again. Example number 1. Use the Pascal triangle to expand this one here. So class, we have 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. This is for n1, n2, n3, and n to the power of 4. So a plus b to the power of 4 here. So a plus b to the power of 4 equal to 1, the coefficient here, and multiply with a to the power of 4, b to the power of 0, plus 4, a power of 3, b to the power of 1, plus 6, the third here, a square, b square, plus 4, a b cubed, plus this one here, 1, a power of 0, b to the power of 4. So b power of 0 equal to 1, a power of 0 equal to 1. So we got a power of 4 plus 4, a cubed b 1, plus 6 a square b square, plus 4 a b cubed, plus b to the power of 4. Okay. So next one here, what's the question then? Okay, the question of b, which is 2x plus 1 over 2y to the power of 3. Okay, let's refresh the coefficient of this. We call the Pascal triangle 1, 1, 1, 2, 1, 1, 3, 3, 1. This is the one that we're going to use here. Okay, so the first coefficient is 1. Multiply with 2x. The n here is 3, so begin with 3 and 1 over 2y to the power of 0. Plus, the next coefficient here is 3 2x to the power of 3 from the, how we call, the maximum of n, which is 3 here, then reduce 1, it becomes 2, and 1 over 2y to the power of, from 0, it increase 1. Sorry guys, because the question here, 2x minus, okay, I make a mistake then, sorry. Minus, it should be negative then. Okay, we follow the question that here, minus, so it could be, should be negative here and negative here. Okay, actually that this one we write we write down as 2x plus negative 1 over 2y to the power of 3 here. So then this is A and B. Next, the next coefficient is 3 and 2x from 2 become 1 here and negative 1 over 2y to the power of 2. And the last final term here, coefficient is 1, 2x to the power of 0 and negative 1 over 2y to the power of 3. Now, for sure that is going to be 1, okay, not 0, 1 here. To the power of 0 is 1 and another 1 here. So look at first, we use the coefficient of 1, 3, 3, 1. 1, 3, 3, 1. Next, look at the first term here, 2x. It begins with 3, then reduce 1, become 2, 1, and 0. Then the next term here is negative 1 over 2y. It begins with 0, 1, 2, and 3. And the addition of this index, 3 with 0 equal to 3. 2 plus 1 equal to 3. 1 plus 2 equal to 3. And 0 plus 3, yes, it's all equal to 3. So it's all complete now. Now, because this is 1 and it's also power of 0 equal to 1, let's simplify this. 1 multiplied with 1 and 2x cubed. Okay, it's not that 2x cubed. For this one, it's not that 2x power of 3. Incorrect. Okay, so the correct way of we call the answers of this, it should be 2 power of 3 equal to an 8 and x cubed. Plus with, okay, we got 3 here. Then 2 square equal to 4x square. And then, what about this one here now? Power of 1 is going to be negative 1 over 2y. Plus with, okay, now 3. 2 power of 1, x power of 1 is going to be 2x. And negative times negative times negative, positive. 1 over 2 square is 1 over 4 and y squared. Okay. Plus with this one here, we have 1. Then 2x power of 0 equal to 1. Another 1 here. Negative cube, negative 1 multiplied with negative 1, negative 1, negative multiplied with negative, positive 1, positive multiplied with negative, yes, in negative. 1 over 2 cube can be come out with 1 over, no. 2 cube is 1 over 8 and y to the power of 3. Now, let's simplify this. 8x cubed. Okay, 4 divided by 2 equal to 2. So, 3 times 2 equal to 6. With negative here, minus 6 x squared y. Plus with 2 divided by 4 is 1 over 2. So, 3 times 2, 3 times 1 over 2 here. Okay, 3 times 1 over 2 is 3 over 2 x y squared. Oh no, positive, positive, negative. Be careful. Negative 1, 1, 1, 1 over 8 y cubed. There you go. Okay, so please listen and follow the step of my explanation one by one. So once you try a few questions, then you will recall mastered. Okay, you will fast calculating is we call inside your brain, and you know what is going to happen. We call what you get at the end of the solution here. Okay, factorial notation. Factorial notation is also important in this topic. So first one, 2 factorial, meaning it's a 2 times multiplied with 1. 3 factorial, which is 3 times 2 times 1. 4 factorial, we call the arrangement of numbers from 4 multiplied with less until they end up with 1 here. Okay, and n is a positive integer. 0 factorial equal to 1, and n plus 1 factorial will be equal to this one here. Example number 2. Okay, for this one here now, 10 factorial divided by 7 factorial. 10 factorial first, which 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1. So look at this one here now. We have 7 divided by 7, 6 divided by 6, 5, 5, 4, 4, 3, 3, 2 with 2, and 1 with 1. Meaning all this, we can simplify this because they are actually divided by themselves here. So finally we get is 10 times 9 times 8, which is equal to 720. Okay, or we can also make simplify this with as 10 times 9 times 8 times 7 factorial. Actually, that this one explaining we call the same question on the top there, divide by 7 factorial. So 7 factorial divided by 7 factorial. So 10 times 9 times 8 equal to 720. Okay, wait. This one here. Okay. Let n and r be the whole numbers with n is greater than r, then, okay, NCRC we call, meaning that, okay, when we comes to this term, so class, actually that this is also the things that you have seen before in the topic of permutation and combination during your SPM studies last time. Okay, and this bring up the meaning of n factorial divided by n minus r factorial multiplied with r factorial. Okay, so for this one here now, 5 and 2 is gonna be 5 factorial divided by 5 minus 2 factorial and 2 factorial, which is 5 factorial divided by 5 minus 2, 3 factorial, 2 factorial. So class, it is, okay, before that, 5 times 4 times 3 factorial. I'll take the biggest one between 3 factorial and 2 factorial. 3 is greater than 2. So 3 factorial and 2 factorial. So divide by this, 5 times 4 equal to 20. 2 factorial is 2 times 1, which is equal to 2. Then we get it 10. Okay. So class, actually that this we call notation here it will give you the coefficient of 2. And what is that? Okay, wait just now. NR notation. Okay, what about this? 1 and 1. Don't they have the notation, NR notation, something like this? Do they have that? Let's try with this one here, which is 2 and 0. 2 factorial divided by 2 minus 0 is 2 factorial and 0 factorial. 0 factorial equal to 1. So 2 factorial divided by 2 factorial, yes, it is equal to 1. What about this? Do we have notation, NR notation, something like this? It is 2 and 2. So 2 factorial divided by 2 minus 2 equal to 0 factorial. And R, which is 2 factorial. 0 factorial equal to 1. So 2 factorial divided by 2 factorial, again, 1 here. Meaning, at every single, what you call? Single coefficient, 1, 3, 3, 1. Not just the coefficient that will be called with the red in here, but 1 and 1 also, we can write down in notation of 3 and 0. And this one here, 1 as an 3 and 3. Just like 3, 1 and 3, 2. So, the same thing goes to this expansion here, a plus b to the power of 4. So, we have this 4, 0, 4, 1, 4, 2, 4, 3. Actually, that this also, there's a term of 4 and 4. And here we also have notation of 4 and 0. It gives you 1 and 1. Get it? So what about a plus b to the power of n? Can you write down for the expression of this? So guys, let's continue our discussion for this part here. So binomial theorem, if n is element of recall n numbers there. Okay, so this is the one. A plus b to the power of n equal to, okay, a power of n minus 1, b power of 1, n minus 2, b power of 2, and so on until this one here. So expand 2x plus 3 to the power of 5 in descending powers of x by using binomial theorem. So now, 2x plus 3 to the power of 5. Expand this in descending power of x by using binomial theorem. Okay, so I'm going to write down as at 5, 0. 2x power of 5 and 3 to the power of 0. Plus with 5, 1. 2x power of 4 and 3 to the power of 1. Plus 5, 2. 2x power of 3 and 3 squared. Plus 5. Okay, 5, 0, 5, 1, 5, 2, 5, 3. 2x to the power of 5, 4, 3, and 2, 3, okay, 1, 2, and 3. 5, 4, 2x power of 1, 3 to the power of 4, plus 5 and 5. 2x to the power of 0, 3 to the power of 5. So this one is gonna give you, okay, this we're gonna give you 1, 2 power of 5, 2 square, 2 power of 1, 4, 8, 16, and 32. 32, x to the power of 5, 3 power of 0 equal to 1. Okay, 5 with 1. 5 factorial divided by 5 minus 1 equal to 4 factorial and 1 factorial. 1 factorial is 1, okay? 4, 5 times 4 factorial divided by 4 factorial. Then it gives you a coefficient of 5. Then 2 power of 4. 2 power of 1 is 1. 2 square equal to 4. 2 cube equal to 8. 2 power of 4 equal to 16. 16x to the power of 4 and 3. Plus with, okay, 5 with 2. 5 factorial divided by 5 minus 2 equal to 3 factorial and 2 factorial. 5 times 4 times 3 factorial divided by 3 factorial times 2 factorial divided by this. So 5 times 4 equal to 20. 2 factorial is 2 times 1, which is equal to 2. So finally it is equal to 10. Then 10, 2 cube equal to 8x cube and 3 square equal to 9. Okay, and 5 with 3. What about this one here? 5 factorial divided by 5 minus 3 equal to 2 factorial and r, which is 3 factorial. Again, this one, we come up with 5 times 4 times 3 factorial divided by 2 factorial, 3 factorial. So 5 times 4 equal to 20, 2 factorial, which is equal to 2. Then another 10 here. So 10, 2 square equal to 4x square and 3 cube equal to 27. Plus with 5 with 4. What about this one here now? Okay. 5 with 4. 5, 4, which is 5 factorial divided by 5 minus 4 equal to 1 factorial and r, which is 4, 4 factorial. So 5 times 4 factorial divided by 1 factorial equal to 1. And then 4 factorial here. So it gives you 5. 5. Then 2x power of 1 times 2x and 3 power of 4. 3 square is 9. Cube 27. Power of 4 is 81. And plus with this one, 1 here because the power of 0 equal to 1. 5 with 5, which is equal to 1. Another 1 here. And 3 power of 5. 3 power of 5. Okay, so 5, notation of 5 and 5 here equal to 1. 2x power of 0 equal to 1. And 3 power of 5 is 2, 4, 3. So let's simplify all this. Then finally, the first term here is 32x to the power of 5 plus with, okay, now 5 multiplied with 16 multiplied with 3. 240. 240 x to the power of 4 plus with 8 multiplied with 9. 72 times 0 times 10, 720 x cubed plus with, okay, now 10 multiplied with 4 multiplied with 27. 10 times 4 times 27, 1080 x squared. Okay, then next plus with 5 times 2 equal to 10. 10 times 81, 110 x plus with 243. Okay, so this is the one here. Okay, general term of a plus b to the power of n. So the general term here, this is considered as T0. This is T1. This is T2. And this is T3. Until this one here, this is T to the power of n plus 1. Okay. So the first term here, okay, the first term, Okay, so according to these lecture notes, they use this one as the first term here. Sorry, because I sometimes thinking of some other reference book, they use that as a T0. Okay, T0. Okay, for this lecture note, they use this one as a T first, T1, T2, T3, T4. Okay, this is TR plus 1. Okay. No. Wait, before I make a mistake, sometimes I confuse them with this one here now. Wait. Okay, what's the meaning of this? Let's take a look at T2. T2, so we got N and 1. N and 1 here. Okay, so N and R here. Okay, look at this one. This is N. Okay, this is N. According to this one, R plus 1 and then R here. So look at this, N and R. When R equal to 1, the first is a term of 1 plus 1. When N with R and R equal to 1, for example, it is the term of R plus 1. So when R equal to 1, 1 plus 1 equal to 2. That's it. So when R equal to 2, when R equal to 2 is a term of R plus 1, which is, this one is 2 plus 1. When R equal to 3, then it's a term of 3 plus 1 equal to 4. Okay, class, let me explain here. In some reference book, they use the term of TR equal to NR minus 1, if I'm not mistaken then. Then A, B, the index here is different. Okay, this is correct too. But then, to make a clear announcement here, to make a clear announcement, please refer to our lecture notes at every time of our discussion, including in our examination. This formula is correct too. This formula is correct, but in our maths units, matriculation maths units here, we agree to use this. So if you look to some other reference book and you find this formula, please avoid it, because I'm afraid if you mixed up with this TR and then you're using this, when it comes to this is totally incorrect. Okay, so I make all of yourself clear here. I make a clear statement here. If you refer to some other books and they come up with this formula, yes, this is still correct, but then we are not using this formula in our discussion in matriculation here, especially in KMPP, and we stick with this one, because I'm afraid sometimes the student come up with this TR, the N term, but then the formula, they're using this, which is totally incorrect. Okay, so I made myself clear again, or hopefully that all of you understood. Do not refer to some other formulas that different from this. This is the one. Okay. Okay, so then N, notation of NR, A power of N minus R, B to the power of R. Find the third term of expansion of A plus B to the power of A. So they want it in the third term. Which means that is T3. So R plus 1, which is 2 plus 1. 3 is 2 plus 1. So then we get N and R equal to 2. Okay. And then Okay, according to the statement, we call the question here a plus b to the power of n, where n is n, we call 8 is n here. So we got 8 and 2, a to the power of 8 minus 2 and b to the power of 2. So 8 and 2, 8 factorial divided by 8 minus 2 equal to 6 factorial and 2 factorial. Again, n r, which is n factorial divided by n minus r factorial times r factorial. So the notation of 8 and 2 here, which is 8 factorial, 8 minus 2. 8 minus 2 equal to 6 factorial times with r, which is 2 factorial. So 8 times 7 times 6 factorial divided by 6 factorial and 2 factorial. 8 times 7, 56 divided by 2 factorial, which is 2 times 1 equal to 2. Then you get 28. So this gives you 28. 8 minus 2 equal to 6, a power of 6 and b squared. Okay, find the expansion of this one here. For the expansion of this, find the coefficient of x to the power of 4. Okay, so tr plus 1 equal to the n equal to 8 and r, which is we got x to the power of 8 minus r, and then 1 over x to the power of r. Okay, so 8 and r, the coefficient here, and then x 8 minus r, and this one here, x to the power of negative r. Okay, so multiply between, okay, the multiplication between this and the coefficient is x and x. So it's not 8, sorry. This is x to the power of 8 minus r, and then multiply, so we add up with, okay, addition of these two, 8 minus r plus with this one is negative r, plus with negative r. So positive times negative, negative. So 8r x 8 minus 2r. Okay, so now let's take a look at this one here, where x 8 minus 2r, we wanted to find the coefficient of x to the power of 4. So we call compare with this one here, x to the power of 4. So look at this one here now, because the base are equal for both with x. So 8 minus 2r equal to 4. Okay. 8 minus 2r equal to 4. Then negative 2r equal to 4 minus 8. Just imagine, okay, bring up 8 to the other side, become negative. So 4 minus 8 is negative 4. Then r equal to negative 4 divided by negative 2 equal to 2. So the value of r here is 2. So 2 plus 1 equal to 3, the third term. Then 8 and 2, x 8 minus 2 equal to 6, and r equal to, with this one here, negative 2. Okay, so what is the coefficient here? Because the question wants to find us the coefficient of x to the power of 4. 8 and 2 factor 8 and 2, which is 8 factorial divided by 8 minus 2 equal to 6 factorial and 2 factorial. 8 times 7 times 6 factorial divided by 6 factorial and 2 factorial. 8 times 7 is 56 divided by 2 factorial, which is 2 times 1 equal to 2. It is 28. So 28 x power of 6 and x power of negative 2. Sorry, this is an x here. Then we got 28x 6 plus negative 2, 4. Okay. And then determine the term in which independent of x. What is the meaning of independent of x? It means that it's a coefficient of something multiplied with x to the power of 0, independent of x. Okay, so then again, the expansion if x plus 1 over x to the power of 8, so then tr plus 1 equal to 8r, x to the power of 8 minus r, and x power of r. Okay. Okay, again, we repeat the process of 8r multiplication between these two, here and here, with x and x. So with x, 8 minus r, plus with it is 1 over x here just now, sorry. Okay, 1 over x to the power of r, so which is 8r, x power of 8 minus r, and this one is x power of negative r. Okay, so 8r, x, both with a we call base of x, and multiplication between these two, so we may just add up with these two, 8 minus r plus with negative r, so it is 8 minus 2r. So the question wants us to find that determine the term in which the independent of x, which term. Okay, meaning we're looking at this one, which term. So now we compare between this x, 8 power of 8 minus 2r equal to x to the power of 0. Okay, so we compare the index here, 8 minus 2r is equal to 0, negative 2r equal to negative 8, and r equal to negative 8 divided by negative 2, yes, equal to 4. So then, when r equal to 4, 4 plus 1 equal to 5, the fifth term, which is 8r equal to 4, then x power of 8 minus 4, and x to the power of negative 4. X minus 2, wait. X minus 2r. 2 times 4 equal to an 8. 2 and 4. Okay. Okay, so 8 with 4. 8 factorial divided by 8 minus 4 equal to 4 factorial and 4 factorial. Okay, which is 8 times 7 times 6 times, okay, we have no enough space here, sorry. Okay, this one here, 8 factorial divided by 4 factorial, 8 minus 4 equal to 4 factorial and 4 factorial, which is 8 times 7 times 6 times 5 times 4 factorial divided by 4 factorial and another 4 factorial. So this one here, you can use the formula, we call this formula, or use the calculator, is straightly going to give you 70. Okay, I'm not going to calculate this one by one. You can just by yourself. And when the coefficient is 70, which is 70, 2 times 4 equal to an 8, x minus 8 equal to 0, the fifth term here. Okay. Find the first 4 term expansion of 1 minus x to the power of 6 and find the value of 0.99 power of 6 correct to 4 decimal places. Okay, example 7. Now class, let's take a look at this, where n is 6. So we call the Pascal's triangle again, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So 1 plus 5 equal to 6, 15, 20, 15, 6, 1. Okay, this is for n equal to 6. Okay, so now it is 1 minus x to the power of 6, which is equal to 1 and plus with 1 multiplied with an 1 here, power of 6, and negative x to the power of 0 plus with 6, 1 power of 5, and negative x to the power of 1 plus 15, 1 power of 4, and negative x squared plus 20, 1 power of 3 and negative x cubed plus with 15, which will have 1 power of 2 and negative x to the power of 4 and 6, 1 power of 1 and negative x to the power of 5, and plus with 1 power of 0 and negative x to the power of 6. So simplify this, and I'm gonna give you 1 minus 6x. 1 minus 6x plus 15 x squared. Okay, wait. Plus minus with. Okay, simplify this. Minus 20 of x cubed and so on. Okay, so now 1 minus, okay, we want it, just imagine that 1 minus x to the power of 0.0, okay, 0.999. So just imagine that we have negative x equal to 0.999 minus 1. Okay. Wait. 0.999 minus 1. Wait. 0.999 minus 1 equal to, here is negative 0.001. So x equal to 0.001. So just imagine that 1 minus x, 1 minus 0.001 to the power of 6, which is 0.999 to the power of 6. Okay, as this one here now. So we have this expansion here, 1 minus 6 times 0.01 plus 15 times 0.01 square minus 20, 0.001 cube, and so on. And this is going to give you, use a calculator, it gives you 0.99401,498. So in 4 decimal places, it's going to give you 0.9940. Okay. Okay, next. Expansion of 1 plus ax to the power of n, where n is a negative integer or a rational numbers. Okay. So class, example of this is 1 minus 2x to the power of negative integer negative 3. 1 minus 3 over 2x to the power of negative, okay, rational numbers, negative 3 over 2, or 1 plus 2x to the power of 1 over 2. So as long as as long as the index here is not a positive integer, okay, it is negative integer or rational numbers 1 over 2, positive or negative, then we use this kind of expansion here. Okay. Example 8. Okay, so for the whole of this, expand this in ascending powers of x up to x cubed, x power of 3 terms. State the value of x, which expansion is valid. Okay, so 1 divided by 1 minus 5x squared. This is equal to 1 minus 5x to the power of negative 2. So look at this one here now. It is negative integer. Okay, so now we're going to use this. It begins with 1 plus with, okay, negative 2, the index negative 2, and then negative 5x plus with, again, negative 2, and negative 2 minus 1 divided by 2 factorial and negative 5x in bracket square plus with negative 2, negative 2 minus 1, negative 2 minus 2, 3 factorial, and negative 5x. Okay, I have no space then. I need to write down at the bottom. Okay, below that, the bottom that. Okay, plus with negative 2, negative 2 minus 1, and negative 2, no, minus 2 divided by 3 factorial and negative 5x cubed. And this is endless. You can continue up, okay, until x power 4, 5, 6, and so on. But we limit until up to x power of 3 terms here. So then, 1. Okay, it must begin with 1. It must begin with 1. Okay, so negative 2 times negative 5 equal to 10 positive. So then we have x. Then this is negative 3. So guys, girls, negative times negative equal to positive. And negative 5 square is also positive. So positive multiply positive with another positive here. Okay, 2 times 3 equal to 6. 2 times 3 equal to 6. 5 square is 25. So 25 times 6. 25 times 6. Okay, 25 times 6 is gonna be 25 times 6. 150. 25 times 6 is 150. So we got 2 factorial here. 2 times 1, 2 factorial is 2 times 1 equal to 2. 150 divided by 2, which is 75. So we got 75 x squared plus with, okay, negative 2 minus 1, negative 3, negative 2 minus 2, negative 4. Negative times negative, negative, negative times negative, negative multiplied with negative, positive, positive multiplied with negative, negative. And negative cube, negative 1 cube equal to negative. So negative multiplied with negative, positive. Okay. 2 times 3 equal to 6. 6 times 4 equal to 24. 5 cube. 5 squared is 25. 5 cube is 125. So then, 125 multiplied with 24, which is 3,000. Okay, 3,000. And 3 factorial is 3 times 2 times 1 equal to 6. So 3,000 divided by 6. Divided by 6 equal to 500. Okay, equal to 500 x cubed. So this is it. Okay, so it's a different from the previous where the n here is positive, but right now it's negative or rational numbers. It is different now. Okay, example 9. Expand this. So square root of 4 plus x. Square root means there is a 4 plus x to the power of 1 over 2, positive. Okay, so now it is before we can expand this, we must make sure that the first term here equal to 1. The first term here equal to 1. So then, factorize, take out this 4 and 1 plus 1 over 4x to the power of 1 over 2. Okay? And don't make a simple careless mistake here that this 4 also related with this power of half, which means that it is square root of 4 and 1 plus 1 over 4x to the power of 1 over 2. Okay, square root of 4 equal to 2. So now here it is 1 plus 1 over 4x to the power of 1 over 2. So now, look at this one here. So this is the one that we're going to expand. Okay. So it begins with it begins with 1 and 1 over 4x power of half. Okay. 1 plus 1 over 4x to the power of 1 over 2 equal to 1 plus 1 over 2 and 1 over 4x to the power of 1. And then another 1 over 2, 1 over 2 minus 1, 1 over 4 x squared divided by 2 factorial. And plus with 1 over 2, 1 over 2 minus 1, 1 over 2 minus 2 divided by 3 factorial, multiplied with 1 over 4 x cubed. Okay. Okay, let's simplify this. Let's simplify this. So guys, girl is 1. And here, if you recall, if you calculate it by yourself, 1 over 2 times 1 over 4 is 1 over 8x. This is negative 1 over 2. So half multiplied with negative half divided by 2 factorial and 1 over 4x squared. Simplifying this, 1 over 2 times negative 1 over 2. Then 1 over 4 squared multiplied with these 2 here and divide by 2 factorial is going to give you plus with x squared divided by 128 plus with, this is negative 1 over 2 and this is negative 3 over 2. So 1 over 2 multiplied with negative 1 over 2 multiplied with negative 3 over 2 and multiplied with the value of 1 over 4 power of 3. 1 over 4 power of 3. 1 over 4 to the power of 3 here. It is 1 over 4 squared is 16. 16 times 4 is 64. 16 times 4. 64, yes. Okay. So just imagine that is 1 over 64 multiplied with negative 3 over 2 multiplied with negative 1 over 2 multiplied with 1 over 2, everything divided by 3 factorial, which is 3 times 2 times 1 equal to 6, and it gives you 1 over 1024 x cubed. Okay, class. This is the expansion of this term, which means that now we come up with 2 multiplied with 1 plus 1 over x, 1 over 8x plus 1 over 128 x squared plus with 1 over 1024 x cubed. Okay, so now it is 2 times 1 equal to 2. 2 times 1 over 8 is 1 over 4x minus, class, you should be careful here because of one of this, this is half and times negative half, and this is negative multiplied with negative here. So there are sign of negative in between here. The first is here, 4 here. Okay, it is negative, negative. So it is minus 1 over 64x squared plus with 1 over 1512. 2 divided by 1024, it gives you 512x cubed. Okay, so this is expansion then. And now, state the interval of x, which expansion is valid. For this one here, modulus of x, okay, less than, it is 1 over the value of this, which is 1 over 4. Okay, so it is modulus of x less than 4 or x in between negative 4 until 4. So class, I forgot about something about example 8 just now. Okay, example 8, I just come up with the expansion here. But then I forgot about the state the values of x, which expansion is valid for this one here now. Okay, it is modulus of x less than 1 over modulus of 5 here. Okay, modulus of negative 5 or modulus of x less than 1 over 5. Then it is x lies in between negative 1 over 5 and 1 over 5. Okay, I forgot about this, sorry. Okay, so now, here comes the exercise, which I think that I let all of you to try by yourself. And for this one, I'll give you the answer then. Find the coefficient of x5 in this expansion here. So the coefficient of this is 6048, the final answer. Okay, you'll find out yourself. And exercise 2, expand this up to x cubed and then obtain approximation for square root of 10, correct to 4 decimal places by substitute. Okay, answers all here. Okay, it's already given to you. Okay, class, that's all for today. I do hope that my 1-hour lecture really benefit you and give you what we call information about the content of your topics for topic 3 part 2. So that's all for today. Thank you very much. Until we meet again. Assalamualaikum warahmatullahi wabarakatuh and have a nice day.